Any copies today? I wanted to start this tape off. This is tape 7 of the 1994 series Tsunami. This is my good friend Chris McMillan. He lived with me for a while. In fact, he lived with me while we were making a Sidewinder, and we really did have some good fun together. I have to look back at that time of life and say, yeah, that was a good time. Kind of the good time you want to live over and over again. But anyway, we are building Tsunami, and I just wanted to get this plug in for Chris McMillan. You know, I know he's a cool guy. Chris, you're going to go to heaven when you die. All right, down to the shop and let's get working. All right, on the last tape, we made up the fuse sides, the drawing, the doublers. We have everything sanded out here. What I did, I took each part separately. We made mirror images of everything. The two fuse sides, I held them together and mirror imaged them. Same thing with the doublers. We settled on which side view we're going to use. Midgley has the other side view, working on the graphics right now. So we're pretty ready to, I guess the next step, we're going to join up the doublers. Let's go get some glue and join-o-matic. Hope you enjoyed that little commentary on Chris McMillan. He really is a hell of a guy. Okay, what I'm doing, I'm marrying up now, making sure that the doubler and the fuse side are an exact match. Now, after gluing, of course, we'll trim it in and make sure it's an exact match. It's very important all through the process here to make sure that you're making mirror images. Now, see, this one's on the wrong side. And another thing, I guess I mentioned this on the other video, make sure you're making a left side and a right side. Okay, when they're close enough, when we're all done, of course, we're going to get all the edges nice and true. So what I'll do, I'll split these apart. Now the next step is I want to match, and I do this for my own reference. I put a little X on this one, a little X on this one, a little X on this one, a little X on this one. Now I know when I'm gluing these together, I want to see all the X's. That's so I don't make two reverse image sides. Now I also want to take this edge and this edge, take it inside on a Dremel tool and put a taper in it. I don't want a stress riser. A stress riser means you have plywood, stop, fuse side, because right there is where it'll crack. I want to have it kind of taper down into the fuse side. Now you can see I've tapered this off. If you don't want to do this with a Dremel tool, another good way is just do it with a sanding block, but don't let it end at plywood. Let it end where it's a taper. All reinforcement should end at a taper. You don't want to end, it's called a stress riser in engineering. You want to have the vibration and the forces that go through here kind of taper into the fuse side. Okay, again, it's real simple now. We just line up all the X's. And believe me, I made these where the taper was on the wrong side and ruined them and everything. Oh, man. The X's are cheap insurance. Okay, what I want to do, I want to just put a little line on here where our glue is going to end. Now I've usually joined the doublers with epoxy, but I want to try doing it with thick CA this time. Now what I'm going to do, I cut the tip off. Important thing, cut as much of the tip off as you can so you get some flow out here. I'm not going to put glue on the front last 2 inches because that's where we're going to taper the mount and taper the crutch. So I'll just start with getting some old CA. Now obviously epoxy is the old standby, and this is a relatively new test, and we'll see how this works. I'm always willing to try something new. Actually, I did do planes like this in the past, but right now I'm trying to cut that 8/10 of an ounce that I picked up on the wing out somewhere, and maybe getting rid of the epoxy on the nose will be a way I can do some of it. This will probably be a little lighter. Now I'm not putting glue up on the last inch. The last inch, no. Is thick CA. Most important thing, make sure the X's are together. You get about 30 seconds working time here. Get it up on its edge. and we'll trim it. Now I made the doubler is oversized by about the thickness of a pen line, so I have a little bit of extra material there I can work with. You got to watch as you press it down, it's not sliding off, slip sliding away. Then of course when these are joined, when I have them both joined together, I'm going to sit down and very carefully make sure they are an exact mirror image. Now two things I'll have to do is mirror image them, get the sides even, and then get thin CA along all the edges. Again, the front isn't joined, we're waiting on the front here until we actually make the crutch. That's starting to kick off, yes. Okay, as soon as you feel it start to kick off, press it down. Give it the Hulk Hogan press here. Okay, you can see glue oozing out the edges, so you know we have a pretty good bond there. Now when I did this years ago and I tested this a couple of different ways, this was a little bit lighter, maybe 2 grams lighter, so maybe we have picked up a little bit off of the wing. I don't know yet. We're going to try some creative stuff on the crutch and on the fuselage construction that I haven't really finalized yet. But we will be trying some unique construction stuff, and so okay, just let it sit aside and dry. Now after you do that operation, there's always some little CA that oozes out onto the glass table. And I want to keep this clean. I don't want to nick up the fuse sides as we're pressing them and cutting today. Get out the old glass scraper, scrape it all off nice and clean. Now with the glue off the table nice and flat, can lay the sides together and get an idea. I have to trim some of this, and I'll do this with a sanding block, trim some of this. Inside here, trim it a little bit. Get these to where they're exactly identical. Very important now, especially the wing cutout, especially the front of the wing cutout, because otherwise the wing goes in cocked to one side. So truing this up, again, there's a lot of ways to do it. I have the rough sanding block, that's one way. If you have a lot to do, you could do it with a saw or with the Dremel tool. This is quick enough though. Now, getting them to be exact mirror images. Remember, we started with mirror image sides, mirror image doubles, so we really have to take the same amount off each one. Now I can kind of hold them together and get both of them trued up to the same. Now that should give us two real nice mirror image sides. Now the next thing I want to do is get right along the edge. I want to leave the last inch or two with no glue on it, and I want to just start at the front and work my way right down. And this will kind of seal this up so we get a nice strong spot to mount the top block on later. Rather than kick it off, if you wipe it with the Q-tips, the dust in the Q-tips will give it a nice slow cure. You want to get around all the edges, all the perimeters. Down here where the wing is going to join, that's important. Give it the old wipe it with Q-tips trick. If you use kicker, it winds up not penetrating as long or as well. You really want to stick to the Q-tips at this point. Now, I made fuse sides one time, and this is a funny thing, because I'm sure everybody else did. Not only can you make them two lefts or two rights, that's a pain in the neck. One of the other problems you can have is you married them up, and the wing isn't exactly in the same spot on both of them. The wing is like a 32nd of an inch further forward or back, and then what happens is you wind up with, I don't even want to tell you, the wing in crooked, the airfoils don't marry up just right. It's real important to have mirror images right now. Right now you got to spend the time, just like when you set up the jig for the foam wing. You got to spend the time up front. I'll leave this, I won't even glue this right now, just the top here. Because I want to be able to bend that nose around, wet it a little bit and bend it right around as we put the crutch in. And you can get all the edges nice and true now. And then final check that you've not made two different fuse sides. You can even kiss this side off a little bit. Get the doubler smoothed down so that all the joints that you make on a doubler will have a nice smooth area to grip on. I always run a little bit of glue out onto the wood, so we start with plywood and then wood soaked with CA and then raw balsa wood. I always get that so it's a transition. It's not an abrupt step. Now what I'm going to do, this is why I have the drawing out on a table now. I want to lay out the exact push rod location because I'm not going to run formers in the push rod location. What's happened in the past many times is you put all these formers up here and as soon as you go to put the push rod in, you got to cut them all away. So what I'm going to try, again remember we're trying some new stuff on this plane. We're going to lay out the push rod and then leave the former's end right about where the push rod would be, rather than have all this, don't even know what to call it, all the formers are in there and then you have to cut them away anyway. And then what I'll do after the tail is installed and we're ready to put the top block, I'll put some bracing in here that won't interfere with the push rod. Okay, I'm just marking off where the tail moment arm is going to be on this ship, 18 inches. Standard pattern master tail moment arm. Now what I'm actually doing is laying out the spot where the push rod will be in the fuselage. Everything below here is going to be reserved for the push rod. This is the furthermost point of its travel. And now what I'll do is lay out all the formers down underneath here. There'll be no pipe tunnel or anything, I'll just lay out all the formers right underneath there. So what I did, I just laid out roughly where the formers are going to be. They're 1.25 inches apart. In the back here we don't have to go much under the stab because we're going to put a geodetic former in to hold the tail wheel. Back here we don't need anything, that's just, there's no strength back there. We're going to put some formers in under here, but I'm not going to put them in, well maybe I should put them in before we join this together. I can get the formers laid out in here in fact. But I won't put any on the top because we're going to have to cut them away. And what I found out, you put all these formers in here and then you cut them away for the push rod anyway. So what we'll have to do is just put, up here we'll have to put, let's put them in anyway. We'll put in temporary formers, but we know these are going to have to come out. There's almost no way you're going to get away. Now as we're carving the blocks, it's handy to have these formers in here. But realistically, we know they're not going to be, we can't depend on them for any strength in the final engineering out of the plane. Okay. Now the next step is we want to transfer this right onto the other sheet. So we want to line up the trailing edge here real accurately. And then just start tracing right over. The idea of this is now we'll have the location of the formers marked in. So when we start laying them in, it won't be a problem. We're not going to have them cocked off to one side or the other. And they should, because we're ending at a nice straight 90-degree angle in the back, these formers should just drop right in. They'll all be 90-degree formers. Okay, all the formers are laid out in a mirror image now. So we have two sides with the formers all marked, the doublers all joined. Everything's kind of ready to install a crutch. Next step is going to be to make up the crutch. Now I've got two full boxes of motor mounts and they range in all kind of lengths, sizes. John Gajewski is the one who custom cuts these. And the last batch I got about 200 sets. They were real nice, straight, If you've watched other videos, you've known I've tried different ways of lightening them. One of the ways I don't recommend ever is holes, because where you drill the first hole, that for all intents and purposes, the rest of the mount isn't there. I've tried saw cuts. Now a saw cut leaves a nice radius edge. That seemed to work okay. I've tried pocket milling with a milling machine. I think I have some of them still down here. I'll have to look and see. Try to show this. I made all different odd sizes at one time for custom jobs. I'm going to be making crutches up real soon. But what I'm going to do is go through my motor mounts now and select out a real nice straight set. And the trick is just sight each set. Put the best ones aside. The ones that are crooked, pitch them. Using that one's crooked, forget about that. That can go in the other box. Anyway, from the two boxes we'll find a nice straight set, and then we'll decide how we're going to go about making the crutch and how we're going to engineer it up this year. Now you might remember this set. We made this set down at Joe Kay's. They're done with a ball end mill, but a ball end mill leaves a notch at the front, so I didn't like the ball end mill deal. I saved them anyway. Somebody will want to try that out for sure. And I'm still going through here. I'm seeing a lot of experimental motor mounts that I cut on and ground on and whatever. But what I do want to find is the straightest pair that we have in here. And thank God, always leave them taped. Another trick with motor mounts: when you get a nice straight set, keep them taped together. Keep them in a part of your house where there's a lot of humidity. If you put them in the attic and they dry out, they twist up in a minute. Keep them in a cellar. Motor mounts, all wood, should be kept in a part of the house where there's a high humidity. Good thing to remember. John Gajewski tip from John, who's a professional woodworker. Now I laid out the mounts, sanded them a little bit, get them nice and true. And what I did, I laid out the nose section here. Because what I want to do is tie the motor mounts right into the wing. So I've traced this out. I'll darken that up. And I'll go out on the jigsaw and cut this piece out. Now the idea is that that motor mount then, when it's installed in the crutch, the motor mount will actually connect to the wing. This whole front of the wing here is going to be a nice solid gripping area for the the vibration and the torque from the body to go right into the ring. Remember, what we're trying to do with the crutch is connect the wing to the body. Make that connection. When you end these motor mounts up here, well, maybe that's okay on a 35 ship or something, but on a 60 ship, you like to run the mounts at least back to the high point of the wing. That's always the technology of choice if you want to get decent motor runs. So anyway, we'll go back by the saw. I've traced them both out, cut these off, and I'll be ready to start the crutch. Now you can see with the cut already in there, when we line up the crutch, we'll be actually connecting this right to the high point of the wing where the plywood and the bell crank mount will be. This will tie it in real nice. It'll be a real solid nose construction. And solid nose construction is the thing that makes a plane last 8-10 years instead of 1/2 a season and it's over the fence. So this is a time where you really have to, just spend some time engineering this up and getting it right. Right, step one is I glued the 6064 or 20. These are 2024, I think. The aluminum pads. But if you're going to use pads, and I suggest no matter what ship you use pads. What this does is it doesn't let the motor sink down into the mounts after 6 months or a year of vibration. The bolts don't come loose. You kill off a lot of vibration this way. These aren't drilled yet. I'm going to drill it for this specific motor. What I do, I C8 them right to the mounts as the first step. That's step one, is get them glued right to the mounts. Then I'll mark off the holes by lining up the motor here. I will do this off camera. If you want more details on making up a crutch like this in detail, the fuse construction video is the way to go. Obviously, we're going to use 632 bolts, 632 blind nuts, no 440s here. And we're going to build this crutch straight with very little or no motor offset. So next step is going to be take it in, mark the holes here, and go drill up the holes. I like to radius all the edges of the aluminum. Whoop. Even the front and the back, it makes getting a tank in and out a lot easier. Get some radius on all these edges. Get them to run true to the mounts, get a nice parallel fit there. We're going to grind that all off later anyway. Now the reason for having a radius in here is if you look at a Super Tiger 60, usually their machining is not so great on the, right up on the case. And what this does, it allows to get a nice fit in there rather than having it that it's sitting up on a lip like that. One of the things to keep in mind with Super Tiger 60s. Again, if you're making a ship and you're making a crutch for a Super Tiger 60, you know you can go back and retrofit the Russian motor or the VMAXs or anything. But once you make the thing too small, you're in trouble. You can always put a 51 where a 60 goes, but to reverse it, it's not always possible. Alright, I'm cleaning off all the glue. I had these taped together for so long. And they are nice and true, though. They really are nice and straight. Okay, next step, I'm going to drill this out for the motor and then bolt these right to the motor. Now what I did, I just took a piece of 1/8 inch music wire and grind it to a point on a grindstone, get a nice point, and you can use this to mark out the location of the bolt holes. Now when you do the rough alignment, you want to allow 1/8 of an inch here. I'm just going to do this by eye. Allow 1/8 of an inch for the nose ring and maybe about 20 thousandths of clearance. You could just run this down there and this marks the holes real nice. Get the mount pressed right up on the motor and we just go drill the engine out. Now what I like to do is just spot drill each one. I've marked it with that pointy tool. Put an 1/8 inch spot drill in there and then go to the motor and make sure that these are showing right in the middle of the motor mount holes. Because the idea here is we want to make this for a stock motor, a completely stock motor, and then we'll over drill the motor just a little bit to get the offset in. Now what I do is I just draw the blind nuts down in, put a drop of WD-40 on the bolts, and that keeps the CA from going down into the blind nut and locking the bolt to the blind nut. You got to recess the blind nut a little bit. Put some CA around here. Hey, where'd it go? And then I'll build a little fillet up with the thick CA. Once I get these torqued down a little bit. If you get a split in the mount like I just did, just fill it with CA. That's the best thing I know to do it. Now after I get the nuts in and I have a little bit of WD-40 on the threads, I take a little bit of CA on the end of a Q-tip that has the cotton off and just get in there to seal that wood up. I like to get that wood all sealed up. Then take another bolt and just run it through there before it kicks off, so a little bit of the WD-40 will get on the threads. Now if you screw one up and you get all stuff on the threads, just run a tap down through it. That seals that up real nice. Now I'm also going to put 2 wood screws in here just to hold these in place. The only purpose of the wood screws is so when you're working on a plane these don't fall out. Okay, now one of the steps, I want to leave out the steps here. I put the bolts in hand tight. Just make sure they're hand tight. Now what we want to check for is a couple of things. Make sure these are tight. Take some kind of a measurement up in the front here and make sure that you have the same clearance side to side, or if it's not equal, that it's pointing outward. In this case I have it pointing outward maybe 1/2 of a degree. Okay, second thing is take your drafting tool and see that you have the same dimension here, same dimension here, same dimension here. Okay, last thing, clear off a spot on the table that you know is real accurate, real clean. Make sure you don't have any little things of hot stuff on the table. And make sure you have it level from the back of the pads back. Sight down it, make sure you haven't put a warp in it somehow. Okay, now we're ready to fill in between the mounts with 1/2 inch wood. I'm going to go over to my pile, get a piece of 1/2-inch scrap. Doesn't have to be the lightest piece in the world. And we're just going to fill this whole thing in with 1/2-inch scrap. Now what I did, I cut up some 1/2-inch scrap blocks here. And what I'm trying to do now, I don't know if you can really see this, is I'm trying to get a nice tight fit here. Now some of them, see that one falls right out. Get rid of that one. Some of them are a little bit too big and they spread them out. So now I can just go through. Getting a nice tight fit on this is very important. See, this one's no good. This one's a little bit oversized. And you could just play musical chairs here until you get a nice tight fit. Really only need 3 of them. And we can get this, just get it sanded in until we get all the fits we want. Nice and straight. The idea of this is you're building a pre-stressed part. You're building a part here where the stress is already built in. When you build a fuselage and you don't have the motor as part of the building, well, you put the motor in place and then tighten the bolts, the whole fuselage goes and twists and everything. This is the best way I know of. This is absolutely the best way. Pre-stress the part. Now this motor is being built like you're building a body around the motor. The motor is already in position. Okay, this is one. I got to trim this one. Anyway, you get the idea here. We're going to trim them and trim them till they all fit nice and tight, and you have the same dimension front to back. Get the same dimension front to back right now. Make sure it checks out. Okay, and then we'll get a nice tight fit on these before we glue them in. Now see, that's what I want. I want the same tension down the whole piece without the glue. All right, I'm going to mix up some epoxy. Get the epoxy heated up real nice so I get a good bind, and then tape this all together so we have one nice tight pre-stressed part here. And what I'll do, I'll mark these so I know, this is just for my own reference, which goes where. And now I know this is 1, 2, 3, 4. I won't get them backward, sideways, crooked, or anything while I work on this. Okay, let's mix up some epoxy and get this guy cooking. And what I did, I took some CA, joined the 3 parts together now that I know I have a tight fit, and now I can just get a nice edge on here. What I'm going to do is mix up the epoxy real well. Get one side of the wood coated well. Now, it's in the end grain here is where you really have to get it to soak in. So what my technique has been for doing this, now I've heard people that do this with CA, but it just goes too fast. Somehow I don't trust it. I like the idea of epoxy here. Anytime you're dealing with hardwood, epoxy is a good idea. Okay, get one side, give it some heat. Now what the heat does, the heat lets it get right in there, soak right in. Anytime you have end grain, you want that to soak right in. Let it soak. Same thing on the other side. Now I don't like to put a lot of heat. If you get the high setting on a hairdryer, it's not like doing epoxy glass cloth. You don't want to melt the epoxy and you don't want to kick it off. I want this to dry overnight. That's the next thing I want to happen. So once we tape this all up, we get this put aside to dry overnight. But this gives us a little bit of working time. This is really big gym technology at its best. I have never seen a better way to build a fuselage. And I've built all kind of crazy fuselages, and they were nowhere near as good as this. Again, you can see it's really starting to soak in. What was sitting on the surface is really really going right in like a sponge. Get a good soaking in there. Okay, let me put this aside here for a second. Get a good mix on the side of the mounts here. Now the mounts, it's not necessary to heat it because this is hardwood. You just need a light coating here. You want to make sure you get a good coating. This is, if you've never built a plane with a crutch and you go through and build one like this, I guarantee you'll never be building it any other way. The motor will run right, fuel doesn't foam. This is absolutely the best way. Small cowling, no big giant Bombay door cowling. 16th plywood, and no holes in the mounts, no drilling holes in the mounts. And you'll definitely have a good motor run. Okay, we want to slide this guy right in there. Get some of the extra epoxy off by hand. Now we're going to sand it back down flat with the mounts later, so we're not all overly concerned about that. But right now we want to get some tape on here. Tape is just to hold it in position while we line it up. And a good spot to put the tape is right over the joints. That'll let it move around in there and find itself a nice joint. This is a part of the airplane that's going to do a tremendous amount of work in the life of the airplane. It's not going along for the ride, believe me. It's not like a wingtip or something. It isn't going to do anything. Now each time I go around, I'm stretching the tape tighter and tighter. Okay. You can see the epoxy's already starting to come out. I'll just get this to lay back down flat. And we'll sand it flat anyway at the end. Tomorrow when we come down and work on it, it'll be nice and flat. And always let it dry overnight because it's a pre-stressed member. Now you're building the stress in here with the motor already in place. So when you take the motor out, the stress is already built right into the part. Now if you happen to have a wood vise, I don't have a furniture vise. A furniture vise would come in handy right now. I guess you could even put this in a normal vise if you wanted to. But this way seems to work, and it's cheap and easy and everything. The tape method. Just constantly baby it, get the extra epoxy off. It'll make sanding it a lot easier later. Work your way down this. And I hope, if you don't get anything else out of this whole set of videos, or out of videos period, learn how to make a crutch and learn how to make a fuselage. And you'll be light years ahead of the guys that are still fooling around with Bombay door cowlings and vibration, fuel foaming, all that nonsense. Now, a lot of people cry the blues about this, that a crutch weighs 3 ounces or whatever it weighs. Well, any plane I've built that didn't have a crutch of some kind always had vibration problems, always had, especially if it was a 46 or a 60. And I'm just stretching this as tight as I can right now, going right down the whole crutch. Actually stripping the tape here, I'm stretching it so hard. But if you see this once, I think you only have to see this once and you can go out and guaranteed you'll have good motor runs. Look at the pattern master plans, the cardinal plans, whatever set of plans that use this type of construction, of which there are many. I think Busso's got this on most of his sets of plans. Good technology. You can't go wrong with this technology. Okay, and we're just going to put that aside to dry. We'll come back tomorrow morning. We'll clean up later. Put it aside to dry. See you in the morning. Now this morning I took the tape off, flat sanded this all down, did the test again with the motor still in position, make sure it's still flat on both sides. Real good. Turned out to be a real nice crutch. Except I'm choking on the sawdust here. Alright, a couple of things I want to do. I have the big belt sander up here. I want to taper the nose in on the belt sander. And then I'm going to put some lightning holes in the back here and channel this out. I'll do that with the big belt sander. Obviously, if you don't have a big belt sander, a Dremel tool will work fine too. Now what I try to do, took the motor out, took the spinner that I'm going to use, and try to look down from the top view and get an idea how much more I want to take off the mounts. I want to take about, I want to blend this into the spinner. And I need to take about 1/16 more off and just leave a little extra. And then what I can do is I can get that curve real nice in there. Blend it right in so I have the same curve of the spinner carved right into the top of the mounts, and I'm allowing for the fuse sides here. I'm allowing even a little extra for the fuse side so I can blend it in. But I don't want to cut into the plywood any more than I have to on this. It's real important to hold this at a 90-degree angle too. And I dressed a lot of this off with, just dressed it off by hand. Married it up to the spinner. It looks like we have the kind of a contour that we're going to like. By the way, putting that curve in there adds a lot of strength to the fuselage side too. A curved side is a lot stronger than a straight side, so getting that curve in there kind of is an important thing. You get that curve in the back now. Now one of the last things I want to do here, tighten down all the bolts, put the motor back in, and then trim the bolts even with the blind nuts. So that when we do the assembly and get the top block on, we don't wind up having you know, the bolts come up through the top block. And then this set of bolts will be part of this aeroplane from this point on. Now all of the 60s that I've had over the years seem to have the shim at least 1/8 of an inch even with the aluminum pad. So what I'm going to do is I'm going to glue that shim right in place, even with the pads. That'll give me, now instead of a piece of wood, 10-grain piece of wood going along for the ride, what it'll be attached to the mounts, and it'll add some integrity and strength to the nose by doing that. So I'm going to look through my source of wood here and see if I have some real hard C-grain wood. Because that'll be, in fact, maybe what I'll do is I'll put 64th plywood on one side, because that's going to become the tank shim also. Now I'm going to do this with 2 pieces of 1/16, grain going 45 this way, second layer of grain going that way. So I'll have some geodetic strength built into the crutch also. After I get the first layer on, just trim. Okay, here we got the grain on the first one in. Now I'm going to lay out the second piece, and I'm just using up scrap 16th here. 45-degree angle the opposite way. Now there's other places on the plane where we're going to do what I call geodetic balsa plywood. The grain all goes corner to corner. There's other places on the ship where we're going to be making bulkheads and things out of this. This is just like an introductory part. Grains cross. Now at this point you can see the grain on the bottom layer, top layer. We're going to be even with the pads, and I'll veneer this over with 64th plywood. That'll make a nice solid tank for the tank floor. Now just do the same thing. Just get a brand new X-Acto and trim it off. You'd be surprised how much that geodetic grain adds to the strength of the part. Now we just want to trace out and cap this with 64th plywood, but I want the grain going side to side here, so I have to see which way it's the strongest. It's the strongest this way. And just trace this out. This will give the tank a real nice base to sit in. Nothing worse than having a soft tank. The wood by the tank gets soft, and then the tank shim changes right in the middle of the season, usually right at the gnats. There you have one nice, rigid, ready-to-go crutch. Now the trick with any crutch is to get as much wood touching the mounts as possible. Now we have really a good lamination here. There's a lot of wood. This is as rigid as can be. And we want to get as much of the wood of the top block touching here. That'll really dampen the vibration nicely. Really be an effective crutch. Now we took a carbide ball end on a Dremel tool and just gouged this out. Put some lightning holes in the top of it. Again, more of this is on the fuse construction video. If I've skipped any steps, I'm sorry, but working under some adverse conditions here. Anyway, I obviously didn't go all the way through, and obviously this is not a part of the plane you're going to see, so you don't have to make yourself crazy about it. Just dig out a couple of grains of the raw wood. Alright, this about finishes the crutch construction. The next step is going to be put the crutch in the body. The tank shim is going to end right where the leading edge of the wing is. We obviously plotted that out. Just want to give you a little close-up of this so you can get some idea of this is probably the single best idea in the world of model aviation, and Jim Greenaway deserves all the credit for it. This is his little baby here. Never seen a crutch built this way that didn't have a decent motor run. Good technology. Hope you can use it. Okay, just did a little rough fit to check that everything fits. The next step is going to be to put this crutch and the fuse sides together. Now we're about ready to get this fuse snapped together. Now what I'm going to do is I'm going to lay this on the table, hanging off toward the camera here. That's the only way I can get a good shot of this. All right, a little bit better shot here. We have to account for the fact the blind nuts stick out the back, so I can kind of bring this up as close as I can to where the blind nuts are. We'll lay out a fuse side in here. Just tie it in. Now I'm using the table. This is the flat part of the table to marry this up. And what I want to do, I want to get a mark on here relative to the front. And make sure I'm not crooked here. Okay, I'm not going to glue it any further than this. In fact, I'll lay this out this way. I want to get about halfway up the mount. Alright, and that's just going to let me have an idea how far up the glue is going to go. Now notice one thing here. Notice before we even glue this, toward the end here, we have the balsa wood with the plywood with a taper. Then we taper in here. There's no point where we have a stress riser, or we've minimized the stress riser as much as possible. Now what we're going to do here, just get some slow CA on here, press it together, and get the first side on. Now if you're going to do CA, it's always a good idea to, just before you put the CA on, get some dust on there. Leave the sanding dust there. The sanding dust helps kick off the CA. That dust will be a big help. We got the slow drying CA. Now we have the line on here. I like to do this without kicker. Squeeze out the extra, kind of wipe it off. Now we have no glue from about the middle of the motor mount pads forward. I just sit here and let that kick off. As it's kicking off, we'll just check that we have a 90-degree, yeah. Okay, close enough. Now we'll just hold that in position for a minute or so and get ready to line up the second one. Now before we put the second side on, I want to clean off all the CA that's oozed out. Otherwise you don't get a nice true flat surface. Now this is the important part, is to get that little draftsman tool, whatever it is that you want to call it, in by the wing root, and get the two fuselage sides so that the front of the wing is even. Now it's a big mistake to go and do this and reference off the spinner back plate or something that doesn't matter. What we want to do is get the wing in alignment here. Let's get this back off where it should be. As soon as I get it in position, I can just run a little mark here where I'm even. Now I just double check this a couple of times. I have two little marks in here that I'm going to line up, because I'm only going to get a minute or two. Don't have any glue on this yet. I'll do it from both sides in. Again, I want the front of the wing and the back of the wing to be at 90 degrees, and when it's at 90 degrees, this lines up just the way it should. Okay. Now I'm just going to get this over the edge, line up the two lines that I have inside, give this a little bit of a check here. That looks real good. Got the height right, back's right. And I'll just press it together. And again, I'll let it sit here for a few minutes before I pull this up. While it's drying, I can just go back and check this over and over again, where that is right on the money. Right on the money. Okay. Okay, we'll just let this dry. I just want to get in there with a couple of drops of thin CA here. Kind of let that seal up before we start working on it. Let it go run, let it just run right down the edge. Now we still have the nose loose. Nose is not on tight yet. We still want to put that bend in the nose. Just get our edge roll trued up.
Craig's going to need some instructions on what to do. We'll be down in a minute.
Okay, the trick here is to get, I'm just pinching this with some CA inside. Get the plywood pulled over first. Get that glued to the mount and then glue the side to the mount. If you try to pull the whole thing over at once, that's why we didn't glue this in the very beginning. If you try to pull it over all at once, you have a problem. Now, let me just get this up close. You can see the doubler is glued right on there. And now I'm just going to get some thin CA in there and push that over, and I'll have the whole side on. Okay, I have one side glued up. Just waiting for the second side now. Put a little kicker on that to make sure it doesn't spring. And it's that curve that you build into the plywood. It adds a little bit of strength to the nose section. Well, I got all the sides all glued up here. Just going to dress off some of the edges. And now you can see the curve we have built in. And it's that curve right up in the nose that's going to blend into the spinner, and it means we have the plywood right up to the very end. We have the tank shim doing some work, a Q-tip's glued to the body side here. Come on, turn over. Boy, oh boy. Just give you a little idea where we sit with this right now. Next thing I want to do is make the tail post. Just take a piece of 1/8 inch scrap. Just make it an 1/8 inch square is all you have to do. Let it hang out, in fact. Now what I do is make this plenty long and then sight down the fuselage. And this is just a temporary pin because we're going to need some material here to put the hinges in for the ray rudder. Sight down a fuselage and eventually you'll get it where it has a nice bow. It's right about even. As soon as you have it about even, just put a couple of drops of CA on it. And just tack it in position first. And the best thing is just tack it in position. Then you almost have to break it to get the bow just right. Sight down and see that it's straight. Once it's straight, then you want to run your hand back here. It kind of opens up the bow. When you get it just right, and what you want to do is just sight down it, and this is the best way I know. Whoa, it tips over. Look down it until we get the form. It's still flexible and flimsy. Okay. Ah, it just sprung open after all that. Okay, we're just going to glue this back again. See, I really try to do this as light as possible, just tacking it before I make it permanent. Now, because the fuse sides have a 90-degree back, if this has an angle, this doesn't work. And because we're starting with everything in 90 degrees, all the formers should turn out to be little boxes. And what we're going to do is just start around here and just start working our way back, putting every other former in place, just to see how rigid it is with every other former, before we start adding formers, and we'll see how many we need to make this as stiff as we expect it to be. Now the grain on all the formers is going to go side to side. No grains up and down. All grain side to side. Alright, I put in the bulkhead that sits right in front of the wing. What I did, I took 3 pieces of 16th with the grain going corner, and across. That's for that bulkhead. All the other bulkheads are 16th. Grain going side to side. And because they're just boxes, you can just drop these in with a tri-square. This is going to go real fast. And it's shaping up just as good as I possibly could expect. But there's a problem. The wife says it's time to stop playing. She came down here and read me the riot act. So I'm going to put the toys away for tonight, get back here tomorrow and get all the formers in and work up the nose section. Okay, this morning I put in a couple of the formers, and I've just been putting them in random spots to see how many I need before this got as stiff as I expected it to be. I may not have to put them all in. I'm going to put every other one in, see how stiff it is, and then put the ones in between. Now, because they're 16th, we can really put twice as many formers in, and usually that results in a relatively stiff fuselage. If you take 1/8 inch and just make 3 or 4 formers, it's nowhere near as stiff as if you put twice the amount of formers and put them closer together. Because what you're doing, in effect, is making smaller boxes. Now, one of the things that's a real pain in the neck, and I can't even tell you how long it takes to put the geodetic formers in if you have never seen that last year's ship, and all the pipe planes were all geodetic because you have that big tunnel in the bottom. This way, every single former is exactly a little rectangle. And so what happens is, notice I've left the trough for the push rod. What happens is you just go along. You want to put this former in, you measure it. Go over to the wood, take the 90-degree triangle, cut a former off, drop it in, go to the next one, measure it. In a matter of maybe less than an hour, you have all the formers made. And the fuselages are perfect. I mean, it really, this came out so nice, it's unbelievable. Just perfect. So this is a real easy way, a real quick, easy, not too complicated way to do this. If you choose you want to make a body this way, hey, this is a lot easier than geodetic. And I think it's going to be just as strong after I put in the right amount of formers. And again, I don't know how many until I start making it. Now to make up a form, another tip here, if you can, is try to use C-grain wood. Now you can do this one of two ways. I like to measure it with a ruler, and then I just allow for, let's see, let's do this one right here. Allow, okay. You can transpose that number right down onto the wood. Cut it with a 90°. That's what's nice about having this drafting tool. You can just make the cut. I like to hit each corner. Leave the dust on. The dust kicks off the CA. Now it's a little bit on the tight side. Again, you can just adjust it. Leave the dust on as you adjust it. Hit it with hot stuff and you have another former in. Now an even quicker way of doing this, if you're looking to really save all the time you possibly can, is just take the wood, make sure you have a 90° edge on it. If you don't start with a 90° edge, you're going to get a pretzel for a body. Take the wood right over to one of the marks where we marked up our formers and walk right off of that with the X-Acto knife. And by having the 90° edge, I want to show you both ways of doing this. It really is a nice, easy way to make a body. The geodetic way might be a little stiffer, but boy, you can spend the whole day putting those formers in. This way you're talking about maybe an hour tops. And you'd like to get them to be a press fit. Now, it's not really super important where you get these right exactly in place, but it's nice if you can get them. I got these spaced 1.25 inches apart. Then sight down it and see if, now sometimes you've bowed it out or it's not tight. You want it to be, push it back until it's tight without even gluing it. Make sure you haven't bowed it either way, that's fine. It gives you a lot of nice adjustments here to do this. I like to run the CA from both sides.
Just looking short of cookie. 74. Thanks, Jake.
So you can see that the whole fuselage went together less than an hour. Try to true up these surfaces a little bit. Up here we needed 4-inch wood, back here 3-inch wood. Let's get a close look up at this before we go on. Now, having made this fuselage in such a nice, really went together well. Went together fast, if nothing else. All the formers in here right now seem like I needed them all. I want it to be relatively stiff. And believe me, this is nice and stiff right now. These I'm leaving in here. These obviously will get cut out. Some of this will get cut out for the push rod eventually. In fact, once we have this all assembled, we may get rid of some of this material in here. Notice we have the triple lamination of 16th for that former. And I guess we're going to start working on the nose section now with this piece intact. And you can just take and do this. And you can see constantly as you put the formers in, you know, maintain the integrity of it here. And it should be, from having watched this video, it should be almost anybody can just snap one of these together. All these formers are complete rectangles. There's no geodetics, there's no angles. Nothing complicated about doing this. Another thing too, when we put the tail wheel in, we'll put the tail wheel in on about a 30-degree angle. That'll stiffen up the whole back here. In case you're wondering why there's no formers back here. Always put the tail wheel, little plywood former in on an angle. That adds some rigidity to the back end too. I like to put that right underneath the stab if I can. Now you can see this is, we just line it up here to make sure we haven't missed a boat here somewhere. Put it right over the plan, get an idea of what it's going to look like. Now here's the thing I always check for at this point. No matter how you do the fuselage ribs, no matter if you do them geodetically or not, is grab the last former, where the tail is going to be, and the back of the wing where the wing is going to be, and try to bend it. And this is about as rigid as you can ever expect it. We can't really tell how stiff the nose is going to be till we get our tank box in, but believe me, this is nice and solid now. And this is the bones of, this is the part of the plane that's really going to do all the work. The nose carrying end of it and the tail carrying end. Everything else now, the blocks and all the carvings and things are really going along for the ride like wingtips do. This is the bones. This piece here that we have right here is what's really going to do the work for us. The next thing I want to lay out is the tank box. So obviously I want to make sure a tank fits in here. And it does. And now what I'm going to do, I'll do this up close so you can get a better look. I want to make it so the tank can't do this inside the body, cock back and forth. So I want to lay the tank in here for now and just see what kind of dimension of wood we need. We need to build a little ridge up on each side so the tank is kind of a nice tight fit. And I'll make the thickness of the tank plus maybe 1/4 of an inch so I have some room I can shim the tank up and down. Now what I want to do, I want to definitely get the grain going straight up and down here because that'll resist the twisting force of the fuselage the most. I'm going to cut the pieces 1 1/4 inches. Now it may not sound like a significant thing, but you do need to have the grain if you want to get the maximum strength out of the wood. The motor is going to want to twist and the wing is going to want to resist. So you don't want to have the grain this way. You want the grain going straight up and down. And we'll make the tank box 1 1/4 inches. That'll give us plenty of room to shim the tank. Remember, the tank shims just go along for the ride. There's no point making, bulletproof tank shims. Now I cut 2 of these pieces out, joined them together, and now what I want to do is I want to make mirror images. I want to get them nice and smooth on the edge. Make sure I have mirror images, otherwise the tank box is going to be bigger on one side than the other. The way you avoid that is make the 2 shims, hold them together, and make mirror images. Now it's okay if it's a little less than 1 1/4 inches or a little bit more, or I would say 1 1/4 inches is a good ballpark number. But you want them exactly the same. You don't want to make a parallelogram out of this. What you're trying to do is make a perfectly true tank box. So now I have the 2, and I want to just stack them down on the table. And while they're down on the table, dress them off so they're exactly the same. Now what it does too, it gives you a little bit of a shelf effect for gluing in the tank floor. And we're going to make a geodetic tank floor here out of geodetic balsa, the same as we did the back bulkhead. Now if I just hold this next to a tank, I can see I have about 1/4 of an inch to shim the tank up and down. That'll be fine. Assuming it'll never go lower than the pads, and we have a 64th plywood, this will just about give us exactly what we want. Now, here's another tip. If you make the tank box gigantic, say if you make it so you can raise the tank an inch, all you're doing is you're losing the fuselage integrity and carrying around a big shim that isn't doing anything. You want to have the shims to a minimum. You don't want to have more than a quarter inch. If that tank goes up and down by more than a quarter of an inch, something's wrong with the engine. You better check what's going on. Okay, I get out the slow CA, did a little test fit first. I want the slow CA because I want to have a little bit of a cushion of time before I have to, you know, commit on this. I want to move it around, make sure I have tight gaps all around. Now this tank, this actually is going to add some torsional strength to the fuselage, so it's different than if you're just putting wood in and it's going along for the ride. These are parts you would normally have to stick in as tank shims somewhere down the road anyway, and then they'd just be floating around in there, vibrating and things. This way they're doing some work. They're adding some torsional rigidity to the fuselage. Now you can see we have the first one dry in there. We'll get the second one in there. Now what I do, I seal the edge here because this is going to be an area where we lay the tank floor. So this gives you an alignment for the tank floor. You line up the tank floor here. I just seal the edge with thin CA. Seal everything up in here. This is going to take a whipping after a while. When these planes get to be 8-10 years old, this starts to get mushy in here. Especially right in here, this former here, you really want to seal real well. Alright, now it's a simple matter. We're going to make this tank floor in here, and we're going to do it with the grain geodetic, the same as we did back here. Corner to corner grain. Okay, the first piece we need, we're going to measure out. This is just going to be a pattern. And we'll make sure we get this at a 90-degree angle, this cut here, so it'll maintain this integrity. See, I make this piece a little oversized now, and I just sand it till I get a nice tight fit here. But what's important now is make sure you have that both edges of it are exactly the same. We're going to have to make this 2 pieces long. You can't make it that it tapers to the front or it starts, or you won't have the integrity. So we want to make a complete rectangle with 4 90-degree angles. These knives, I don't know, this last batch of X-Acto knives I got is really, you get 3 cuts and you need to dress them off. Anyway, I have the 2 pieces now. I'm going to join the 2 pieces together, and this will actually just be a pattern for our tank floor. Again, the trick is now we want to get the grain going corner to corner. 3 layers of 16. Remember the old sanding belts glued to the table? It's a good time to use them to true this up. Make sure you have the 490. This is very important. Get the 490-degree angles. Now once you get a nice tight fit on this, and you know that the front is the same dimension as the back, and you have a nice tight fit, now you get the other 2 layers of balsa in with the grain going corner to corner. Now remember, what you're trying to do is get the grain going corner to corner. That means this is not going to fit on 1 piece of wood now. So try to get corner to corner, right down the middle of the wood, and you're going to have to put 2 little pieces on the end here. Now an easy way to do that, I know this takes a lot more time than if you just do it with the grain going in one direction. Just kind of trace this out. This is a good place to use the slow CA. Give yourself a little reference here. There's our slow CA. Now, if you make this out of 1/8 inch light ply, or you make it out of, well, you could make it out of 16th plywood. All of those pieces have some drawback as far as weight and strength goes. This is the strongest way to do it and the lightest way, both at the same time. It takes a little more time to make up the parts, the geodetic balsa parts. Once you start making geodetic balsa parts with the grain corner to corner, you'll find out the planes are coming out lighter, stronger, better. I don't know how many other words we can use here. Now, it's an easy question of just turn this over, take a couple of pieces of scrap that we do have here, and if you have a choice, you always want to have the piece that goes side to side, right in the middle. Not critical, but it will add a little bit of strength. And you can make actually anything that used to be light ply, you can make out of this kind of balsa ply. Save a little weight, and it'll be stronger. The only penalty you're going to pay is it takes a little longer to do it this way. Tank floor can be done this way. Formers F1, F2, if you have those in a design. Okay, now that we have that, we just obviously will trim it out off camera here. Now, when you get to this point, before you put the second side on, I like to dress it off back down to our pattern piece. This way you don't wind up having to do two grains at the same time. Just get it down to where we had the side-to-side pattern. Now, one last thought is you don't want, and I've done this before, I don't want to get the two grains going the same direction. I want this one going corner to corner this way. Always make sure you have them crossing with the cross piece going this way for maximum strength. Make sure you leave the dust on and you'll get an even better bind. Don't blow the dust off. And you can see what a nice tight fit we have in here. Now it's just a question of CA. Drip the CA inside, outside. Don't skimp on glue on this piece. This is not a good piece to skimp on glue. Give it a good squeeze. Make sure you have a nice, nice tight fit. Now from this point on, you can grab this and you can see how solid that nose is becoming. It's absolutely unbelievable how good this works. Now the other thing, I want to get in here and just drip the glue right down inside. Let it run right down to the corners. Let it roll around the bottom. Just let it roll into all the corners. This tank floor actually will do a lot of the work of absorbing the vibration. This is not going along for the ride. I just let it drip in all directions. Let it come down the front, down the back. Okay, I'm going to I made up a little pattern here. The geodetic former that'll go inside the fuselage here. Again, I'll do the same thing. Balsa plywood, grain going corner to corner. 3 layers of 16th. C grain if you have it. Now a good way, when you can't get the two pieces, I'm trying to use up some scrap that I have here. A good way to do this is just go, when you're making rectangles, go corner to corner this way. You get one piece on, trim it, and then just put the other piece on. Very little waste this way too. Now see, you have this extra little piece here, and you can just basically get it in here like so. Always make the pieces a couple of thousandths oversized, and then you just block sand them to fit a nice... Anything in the nose, you want to have the the fit's absolutely tight at any price. This nose is going to do a lot of work, and you know, we hope this plane is going to last many years. So in the course of its life, we don't want it getting worse and worse, looser and looser, like an old shoe. Okay, again, we're looking for a nice tight fit here. Okay, we got the front bulkhead in. We obviously didn't cut the air outlets yet. We haven't decided on exactly how we're going to have that air outletting system. We know we don't want to have any holes in the side just for the scale appearance. So next step, we'll put the motor in and get the spinner on and cut up a nose ring to match the spinner. Now what I like to do is trace out the, using the actual spinner that I'm going to use, the actual motor, everything. So I get the spinner in exactly the right position. And when you cut this out with the jigsaw, leave the ink line on. Leave it slightly oversized, because you're going to have a little bit, what happens is when you pick up the spinner taper, when it gets 1/8 of an inch further back, it's already a little bit bigger, so allow for that. Trace it out and just leave the ink line on when you cut it. I wanted to leave enough material here because we're obviously going to use the nose ring itself as part of the cowl hold down system, so we want to leave enough material here. This is 1/8 inch plywood, real plywood, not light ply. Okay, just check that you have a little bit extra meat for sanding in. Ready to shim this in. Okay, now next thing I do, I take the spinner back plate and just tack glue on. This is a piece of 16th balsa. Tack glue it on. This will become my clearance shim. I'm going to make sure I can get that right in there, that I have the right amount. I want to start with having a 1/16 of an inch of clearance because it's going to build up with paint and epoxy and who knows what else. I want to have that clearance. There's nothing worse than you put the final motor in the plane, you tighten the prop, that pushes the spinner back against the fuselage, and then you have to grind off all the paint, and when you grind off the paint, oil gets in the nose ring and it all loosens up. Just use a shim on the back of the spinner back plate. That's a good trick. Now what I do, I put the motor in position. Just the nose ring is just floating here. I have the spinner back plate with my 1/16 of an inch clearance already fixed up. Now all I'm going to do is, you can see this is floating around, just break off some shims of balsa wood one by one and let it find its own place. And it'll seat perfectly. You won't get, by the way, this is a tip that's worth its weight in gold. That holds it flush. You don't get any offset, any up, down. You can just look around now and see that you want to get it lined up pretty much where you want. And it's a question now of a couple of drops of hot stuff and you have your nose ring fit complete. Now, because I'm going to, well, I want to get this a little solider. Actually, the 1/16 is not what I want. What I want to have, you get some 3/32 and kind of make wedges out of it. This is a little bit harder balsa wood. And what I want to do is actually just crush it right down in there. Just jam it. Yeah, that's better. That's better. Just make wedges. Pinch one end with your finger. Because all the pressure is going to be up on the 1/16 shim. It doesn't matter. This was a pretty good fit, by the way, when it comes out this close. Amazing. Anyway, we do have it now. You can look around before we even glue it, and you can make some adjustments to it. Press it around, move it around. Look at it from a lot of different angles. It still needs to go this way. Make sure you can see that whole pencil line on the whole perimeter. Now the good tips are, make sure you have the pencil line in full view. Feel around it so you have the same amount sticking out on all sides. If not, press the shim in. And you see how that 1/16 balsa just holds it exactly a 1/16 of an inch away. It let you just shove the shims right down. And this is such a good tip. If you try to do this any other way, it can be 10 times as much work. Now we'll just hit this with a couple of drops of CA and we're off to the races. And all you need here is a couple of drops, get it tacked in position before you go any further. And then you can obviously trim it down. I guess if you look at it head on, you can see the angle here. Boy, I have to tell you, I spent a lot of years trying to line up spinner fits and do all this nonsense. This is the best way I know of to do it. I haven't found a better way. If there is, please drop a line. Windy, 93 Elliott Place. 1-800 Stunt Ships. Anyway, let's let that kick off and then we'll trim it off. Hey, in fact, we can trim it off right now. Hey. So you say you're not getting your $15 worth on these videos. Hey, believe me, go do this the old-fashioned way. You'll be sending me 15 pizzas. 1-800 send Windy cash. Send them a pizza. Now after trimming this out, I want to make some little blocks in here to give this nose ring a little extra support. So I'm just going to take some scrap 3/8 wood, make triangles, and push it down in there to give it a little support. Now whenever you make supports, you want to have the grain going corner to corner. So of course it's easier to do it just by making a block any old way, but spend a little bit of extra time and get the grain going corner to corner. It'll be worth it. You can just take a 90-degree triangle and get the grain going corner to corner. This is important because that nose ring is going to be part of the cowl support. Stiffen up the nose. It adds no extra weight. You're going to put a piece of wood in there anyway. You just jigsaw it out and squeeze it right in. I have the two little triangles and I'll just do a little fit here. Do a little preliminary fit. Usually you have to cut them down quite a bit to clear the crankshaft. Yeah, we'll have to cut these about in half. But now at least we have the grain going in the right direction, and that's the important thing. So I'll just slice these off as necessary. Stick them on the end of a knife. Now I know I have to cut some off. And you really have to play with this quite a while to get them right in there. But it's worth it because once you get the grain going in the right direction, when you understand how to build strength with grain, the rest of it will be pretty easy. You see, you have to take a little bit of a cutaway, a relief for the crankshaft. Put it on the end of an X-Acto to do your test fit. Now we're sneaking up on it. And take a little bit more off here. A little bit of time here is going to build a lot of strength. Now another little trick worth its weight is the corner that you're going to go into. Always radius that corner. It doesn't take much of a radius. A couple of hits with the sandpaper and what will happen is it'll fit right into the corner. I don't even know if you can see how nice and tight that fits. And now I'll just put some slow CA on this. Get that up in position, put a little pressure on it. Press it in. Now don't forget that little nose ring, that little balsa shim is holding this in position, so we're maintaining all the integrity of the part, and because it's soft balsa we can just squash it into position. And you can see we have one of them in. I would just do the same thing on the other side. Okay, for right now that's about as close as we have to trim it until we pull a motor out, and then we'll get it all nice and even in there. The next thing is I want to make a little triangle from the motor mounts in here, just a small one to give this a little more support too. Same way as the other one. No, I did because I have a little room around the motor mounts. I made these a little longer than the other side. Give it a little more support from them. Remember, we're trying to take all the vibration from the mounts and get it up into the fuselage, into the top block. The more wood you can have touching the mounts, connecting the top block to the mounts, the better it'll be. Now again, we're just making some test fits, going back and forth until we get the fit that we want. Now one of the things you can do to make this easier is just put a lot of pressure on it and it kind of conforms to the contours. Remember, we have that 16th holding our clearance. I just want to get this to go so we don't... Now remember, the trick is the grain has to go corner to corner. If it goes this way, useless. It'll break right off. This way, useless. Corner to corner on all triangulation. Alright, after a little trimming, and once we take the motor out, we'll get this all radiused and flattened off in this direction. That should hold the nose ring on real well. Should be a good job. I just want to clean this all up. Go over to the Dremel tool, put some nice radiuses on everything. Alright, I don't want to take any of the material of the nose ring away. I just want to go right up to it. You have to work down into that corner. I got a piece of 16 plywood here working down into that corner. Now while I have the motor out, I can kind of clean these joints up, get a little thin CA in there. Getting a nose ring on solid is usually a time-consuming job. This went pretty well. This is a good system though. If you build a fuselage right off of this video, step by step by step, I know you'll have a very good, very efficient, reasonably easy to make airplane. And here's the thing that makes it all possible. Now we're just going to take a razor blade and cut this right off. It's already done its job, but getting that nose ring located exactly where we want it to is a major thing. Major little piece of technology there. Just take it off and chuck it. Alright, next step is we're going to look through the blocks that we have available, see if we can find a halfway decent top and bottom block for this and get the blocks tacked on. We don't have any really killer blocks here, but Midgley promised to send me one and he never did, so he's probably got one good one still left up there. Now at this point in time, I also, before I even get the top block out, I covered 2 layers of masking tape on the spinner. And what this does is if you slip with a knife or with a sandpaper block or something while you're carving in the blocks, or the cowl, you don't wind up eating the spinner for lunch, putting a big gouge or a scratch in it. And since there's no more of these Russian spinners around, these are the last couple on the planet, we don't want to waste one. Now step one is I take the, I try to get this to go right down the middle of the block. Press that on and it leaves a little bit of an imprint, but you know the motor is going to be sticking through. And we can go Dremel this right out so that we can get a nice flat fit on the top block. Now here's a nice little trick. What you can do is take one of these Sharpie or normal marker, mark up the blind nuts in the bottom of the motor, and then just flip it over and press it in. You can see it leaves a nice little impression, and you can see I've carved these 2 out, left these 2 in. I'll just carve the rest of this out. You need to get that flat, tight fit that we're looking for right around the motor. You can't have that just a random thing. Okay, we're just going to trace the outside. I have the motor sunken in. And we'll leave the pen line on, leave ourselves a little extra wood here. What we want to do is get this profile cut off first so we don't have a lot of extra wood when we start cutting out the side profile. So we get the up and down profile first. Now the reason I'm showing this on the video, I had somebody that used to work at my shop who took a top block, glued the fuselage to it, and just started hacking off. Well, this is how much wood you can get off of one side. You can see how much. It's just less carving and sanding and everything. Obviously we'll do the other one off camera, but get as much material off with the saw as you can. Just an idea to make it easier. Now you can see we just left the line on. Leave a little extra material when you make these cuts. Leave the little, we have the little indentation of the motor here. Leave a little extra material. Now we're going to have to add a little piece to the back of this, a little, it goes about 2 inches from the end, so I'm just going to do that off camera. Just take a little piece of the scrap that's left over and glue it up right on the table. Okay, I lopped off the profile of it, and what I did, I just went over to the old drawing and kind of lopped off the profile. I used one of those big 3-wheel bandsaws. What a pain in the neck, the blade keeps jumping off. Anyway, and what I did, I laid out the scoop. I don't know if you can see it under the tape. I laid out the frontal scoop, and now I'm just laying out the center line of the top block. If you want to see some real good footage on carving top blocks, we have that thing on a Fuse Construction video Midgley did. That's about the best top block carving video. Anyway, this is a unique one. I'm going to have to really take my time on carving this up. In fact, I'm not even going to carve it tonight. I'm going to wait till tomorrow. I'm just going to get the lines drawn on it, get it as close to the profile in every dimension that I can, and then tomorrow get out a couple of brand new razor blades and carve away. Yeah, I had a little extra time tonight. What I did, I just got the block ready to be tacked on. Put some ink lines down the tape. Tried to simulate, from looking at the drawing, the scoop lines. Married it up. Try to get it pretty close anyway on the first shot. Just roughly looked at the side view a few thousand times. And what I'm doing now, I'm just going down about every 2 inches and tacking it in. A couple of drops. This stupid CA is leaking again. I always get these lucky draws of CA. Anyway. Get it all tacked up. And we'll be ready to carve tomorrow. Hi, good morning. This morning we're going to start working on carving this top block up. I just wanted to go backwards a little bit here. Maybe in thinking out how many things have happened in the past couple of days, I might have left out one of the steps. One of the steps is I kind of plotted the scoop up on top. From looking at the drawing and the pictures that I have from Joe Adamusco, you know, what I tried to do is interpolate here. And I've just done this by eye again, and I'm just going to rough it out. I roughed out about where that scoop starts. I took the Red Baron down off the rack and kind of lined it up with the Red Baron to see if I had the same look that I'm looking for, kind of like the Red Baron look. All the Reno air races seem to have that scoop on top. That's one of the distinctive features, along with the canopy being in the back. But what's even more interesting about this is I was rethinking a lot of the things here, how I'm going to do the cowling, how I'm going to do the bottom block. Did a little bit of soul searching last night, and so actually talked to Joe Adamusco too. And I'm got even more psyched up than ever about doing this and really trying to make a special job out of it. So what I did get in the mail, and I'll play it somewhere later on in the video or maybe on the next video, I got a tape from Joe Adamusco and a picture of one of the Reno air races that he wants to make. Now, I received this in the mail today from Joe Adamusco. This is some pictures of a semi-scale Yak 3, and he's contemplating making this, and we had discussed you know, various ways he could make the wing roots, the cuffs and things, because I've done that on the Red Baron, and how much taper he could put in the wing. This is one of the things Joe Adamusco really likes, these pointy wingtips. I guess if you've seen his airplane, they're short nose moment on like the Sidewinder would have. So more on this project later, next time we get together with Joe, or and I really try to inspire him. He actually was the one that inspired me with Tsunami, inspired him to get going and do this. But here's the other thing he sent, and we'll play this later somewhere in the video or on the next. We're getting near the end of this video. This may be for the next video here. The Sound of Warbirds and Air Shows at 1984, Volume 8. So. I'm looking forward to hearing this tape. Maybe we'll hear this somewhere later on in the in the series of tapes. All right, we're going to end this tape with just some rough carving, getting started with the carving part of this top block, and it'll just run off to the end of the tape here. What I always try to do is envision in my mind, and this is always the hardest part, envision in my mind exactly what this top block is going to look like. I try to get a little feel for, well, we're going to do a bottom scoop on the next, a Mustang type scoop. We're going to do the rudder on the next video, so, you know, obviously stay tuned if you're interested in this kind of stuff. And I guess this is going to be a kind of a new kind of canopy, carved in back here. Getting the radiuses in here right. It's going to be kind of a time-consuming thing, so I'm going to get as much as I possibly can on the video. So if you decide you're going to do an air racer, or if you just want to use maybe some of these design things in one of your next adventures. One of the things before I start carving, I put on a nice clean sheet, put the pad back up on the table. There's nothing more frustrating than dinging it all up before you even start. And you know, these little tips obviously start with, I took out a pack of brand new number 26 blades. Take out the sharpener, which I don't even know if I've ever shown this on the video. This works extremely well on X-Acto knives for sharpening. Anyway, let's get carving. It's time. Now, see, what I try to do is I work up to the center line. Just nice cuts right up to the center line. I work, in this case, I'm working the back first, and then I'll work the canopy area. But just start on one side, and then try to mirror image it in, go over to the other side, and just with your hand feel to see that you have both sides the same. Alright, we're just about finished with the top block here, the back end of the top block anyway. Now I've got the back kind of roughed in, as rough as I'm going to get it. What I'm going to do is start here up at the front of the canopy and try to work my way up toward the spinner. I always find it's easier to work from the back to the front when you have this kind of a scoop, and if you have a normal front where you just have a spinner, it's easier to work from the front to the back. But either way, you have to carve both sides. And the best way I know of, right, is just keep putting your hand back and forth, carve up to the tape and leave it here, and we'll do the final bit with the sanding block. Big sanding block, and then we'll just sand a line right off.
Make sure your batteries are Joe. Tell her you can't deliver the sofa bed. So now she's taking the day off. And you know what that's like. You sit there and you wait. You're going to come out and hook up your cable.
Exactly.
And there's, you know what? There's plenty to do until you got nothing to do.
Yep.
Until you're just sitting there waiting. You got all. You know what? You run out of things to do. You don't want to do anything while you're waiting for somebody.
And you can't leave the house. You know, it's different. You can't run out and get something. You just go to the store, and then that's the time that they come.
If they're going to hook up a phone or hook up your cable, what time? What's the window? Between 8 a.m. and midnight.
Thanks.
Oh, that's great.
Don't leave the house.
No.
Anyway, she got a call. Ladies and gentlemen,
You got it.
Ladies and gentlemen, the sofa snafu.
One extra number.
Hello,
Yes, who's this?
this is Jennifer Benavides.
Yes, I'm calling from Orphanage.
Hi, how are you?
How are you? We're supposed to have a delivery there today
Yes, you are.
for a sofa bed. There's been a small problem.
Boy. Yeah.
We're not going to be able to be there. Apparently, the gentleman who sold you the bed, his mother purchased the same bed.
You can't do this to me.
Yeah, so she purchased the bed, so she gets it and you don't.
No. You definitely can't do this to me.
The only thing I can do is try to get a driver to swing by there after midnight. I don't have anything available to that. I got guys out, the swine flu, everything is crazy. I mean, I know you're supposed to leave for some sort of trip, right?
I guess I can rearrange things so that I can try and get on a different flight or a different train or something. But, well, I guess, yeah, that would be fine.
Well, when were you supposed to leave?
11 o'clock tonight,
Tonight.
because I specifically took today off so that I could just
Do that. Is there any way
to do anything or something like that, I'm sure.
with
It's brain buzzer. CEO, you
Well, we're at the end of this tape now. Going to try to end this at a clean break here. We've got this roughed out. We'll do the final work and pick this up on the next tape. I hope you're picking up some technical information you can use, and most of all, enjoying it. So pass these tapes around to your friend, and let's get building and carving. Hey, this is a lot of fun. Now, come on, you got to admit this was a fun fuselage to make here. All right, see you on the next tape, guys.